Now we'll start with our third experiment, which is again conductometry. Aim of the experiment is to determine solubility of sparingly soluble salt, barium sulfate and calcium sulfate conductometry. So in this experiment, you require conductometer, conductivity cell, barium sulfate and calcium sulfate powder. So very first, I'll tell you what is the theory behind this. Very first I'll tell you about this, what is meant by sparingly soluble salt. Generally when we take sodium chloride in water, at that time we get a clear solution. So sodium chloride is completely dissolves in water. It is considered as a true solution. But when we are going to take barium sulfate or calcium sulfate, so when we do the barium sulfate and calcium sulfate, when water is added, the calcium sulfate or barium sulfate, or even you can take an example of aluminium sulfate, lead sulfate, they are not completely dissolves in water. Instead of that, some part of it dissolves and remaining powder, or you can say that solid, remains as it is at the bottom, and such solution is considered as a saturated solution of that salt. So this is a saturated solution. Now in this experiment we are going to measure the conductance of saturated solution, and by using that conductance measurement we are going to find out solubility of the solid and even solubility product of that solid. So as I have told you, we need barium sulfate and calcium sulfate. So you have to take 1 gram of barium sulfate and 1 gram of calcium sulfate. So already I have weighed 1 gram of barium sulfate, transfer it in a beaker. Same way, weigh 1 gram of calcium sulfate and transfer it in a beaker. Now to this, you have to add 100 cm cube of distilled water. So I am going to add 100 cm cube of distilled water. Then you have to stir the solution. Stir it carefully and keep it as it is for some time. So this is a saturated solution of barium sulfate. Now you have to filter it by using normal filter paper. So filter the solution by using normal filter paper and collect the filtrate. So filtrate is your saturated solution of barium sulfate. So same way, repeat the process for calcium sulfate. That take 1 gram of calcium, add 100 cm cube of distilled water to it and filter it. So I have already filtered the calcium sulfate solution. Now we'll start with the readings. Now in this already I have told you how to calibrate conductometer and everything. So you have to wash your conductivity cell 2 to 3 times with conductivity water, and then you have to dip the conductivity cell in a conductivity water. Very first you have to note down the reading for conductivity water, or you can say that distilled water. So reading for the distilled water is 0.243 into 10 raised to minus 3, as reading is in millisiemens. Now remove this from the conductivity water and dip it in a calcium sulfate solution. Saturated calcium sulfate solution. So on the display you will get the reading. So your reading is 2.07 into 10 raised to minus 3 millisiemens. So note down this reading in your notebook, and same way you have to take the reading for barium sulfate solution. So very first give the washing to your conductivity cell and then measure the conductance for saturated barium sulfate solution. So this is your barium sulfate solution. Now measure the conductance for barium sulfate solution. So on the display you will get the reading for barium sulfate solution. So your reading is 0.360 into 10 raised to minus 3, as reading is in millisiemens. Now, next you have to do the calculations.
So this is the way to measure the conductance of your conductivity water, barium sulfate and calcium sulfate. You have to also calculate the cell constant as previously shown by Supriya ma'am. Same way you have to measure the conductance of your 0.1 kCl and then go for the formula of cell constant, which is equal to specific conductance of 0.1 kCl divided by the conductance of 0.1 kCl, and you will get the cell constant. So madam is going to show you the calculation how to calculate the solubility and solubility product of the sparingly soluble salt from the conductance measurement. So now madam continue.
So this is your observed conductance for 0.1 normal KCl. So in previous experiment we have discussed how to find out cell constant. So this is your cell constant 0.972. Now next, your conductance of distilled water, that is equals to 0.236 into 10 raised to minus 3 Siemens. And then we have measured the conductance for calcium sulfate and barium sulfate. So calcium sulfate conductance is 2.11 into 10 raised to minus 3 Siemens, and barium sulfate conductance is 0.362 into 10 raised to minus 3 Siemens. Now you have to go for the calculation. Very first, you have to find out conductance of solution. This is also known as a corrected conductance of solution, which is equals to L, that is conductance, minus conductance of water, which is equals to 0.0236 into 10 raised to minus 3. So you have to subtract this conductance of water from the solution conductance or saturated solution conductance. So your answer is this 1.874 into 10 raised to minus 3. Next is you have to find out specific conductance. Formula is same, cell constant multiplied by your corrected conductance. So you will get this answer 1.821 into 10 raised to minus 3. Next is you have to find out solubility. Now formula for solubility is 1000 multiplied by K, that is specific conductance, upon infinite conductance. So 1000 multiplied by K, that is 1.82 into 10 raised to minus 3, and infinite conductance for calcium sulfate is 139.5. So when you calculate it, answer is 0.01305. So infinite conductance for barium sulfate is 149.5. For calcium is 139.5. One more thing, you have to find out solubility. This solubility you will get in gram equivalent per dm cube. Now you have to find out solubility in gram per dm cube also. That is solubility in gram equivalent per dm cube multiplied by equivalent weight. So solubility in gram equivalent per dm cube is 0.01305 multiplied by equivalent weight of calcium sulfate is 139.14. So you will get answer as 1.8168 grams per dm cube. This is solubility in grams per dm cube. And then you have to find out solubility product, that is KSP equals to solubility in gram per dm cube square. So solubility in gram per dm cube is 1.8168. Square of this is 3.30. So this is for calcium sulfate. Same way you can calculate it for barium sulfate. So in this way, the solubility and solubility product for the both calcium sulfate and barium sulfate are determined. So that's all for the experiment.